All right, welcome to Calculus, Limits, Notes, Day 6. We're going to start talking about one-sided limits. So we know that if the limit as x goes to c of f of x has a limit, then we know that the limit had to be the same as you went from the right of c as it did from the left. If not, there's no limit. So we said if this, then this. If this, then this is also true, okay? So if I tell you the limit as x goes to c exists, then you know that the limit as you approach from the right and the left will exist, okay? Now, if the limit as x goes to c from both sides of f of x equals a number not equal to 0 over 0, then plot points or evaluate the numerator and then plot points, do the numerical method, not necessarily plotting points, we're not going to graph it. Do the numerical method or evaluate what the numerator and denominator are approaching. So for example, okay, the limit as x goes to 4 from the left, all right? Now, we know of 3x minus 9, we know this is a line. So we know that the limit as x goes to 4 of 3x minus 9 is simply equal to, since this is a continuous function, 3 times 4 minus 9, which is 12 minus 9, which is 3. Well, if the limit as x goes to 4 is 3, then that also means that the limit as x goes to 4 from the left is 3. Right? So if the function is continuous at the point, this is almost irrelevant if function is continuous. Okay? If the function is continuous. All right? Then left and at C, then the plus or minus is irrelevant. So this is just going to equal 3 times 4 minus 9, which is 3. Okay? All right, over here, what about this one? Okay, well, as we go to negative 5, from the right, we're going to get 0 over 0. Okay, that probably means that the limit exists. So if the limit exists, that means that it doesn't matter if we're going from the right or the left. So I'm just going to go ahead and do this problem like I normally would. Now I'll keep from the right, but I know that 5 made the top 0, or negative 5 made the top 0, so I'm going to factor out an x plus 5. And I know that negative 5 made the bottom 0, so I'm going to factor out an x plus 5. These will cancel, and then I'll put the negative 5 in. Doesn't matter if we're going from the right or the left, because now this is continuous at negative 5. Now, I know this wasn't, but this was. We knew there was a hole, so there was a good chance that the limit existed. So that's going to be negative 10. Okay? Now, what about this one? Okay, so the limit as x goes to 3 from the left of negative 2x over x minus 3. Now, when we put this in, we're going to get negative 6 over 0. So we know that with this problem that there is a vertical asymptote here, okay? So what that means is at x equals 3, we got a vertical asymptote. So as we go from the left, so really the limit as x goes to 3 does not exist, okay? But as we come from the left or the right, I want to know, what I'm going to want to know, the limit does not exist there either, but what I'm going to want you to be more particular here and tell me, is it going to infinity or negative infinity? So one thing that you could do is you could go here and you could do 3, and all you got to do, so this is numeric. This is not my favorite way, but from the left of 3, then we'll do like 2.5, 2.9, and 2.99. Okay, so give me a second. I forgot my calculator. Okay, so you guys can start punching those in. All right, so if I go parenthesis, negative 2, parenthesis, 2.5 parenthesis divided by parenthesis 2.5 minus 3 parenthesis. Ooh, no, wait. 2.5 minus 3. There we go. Equals 10. Okay, let's change this to 2.9. 58. So it's clear it's going up the asymptote. But I want to see this work. This is your explanation to me. This is one way to explain it. Okay? $5.98. So it's clear now with this chart that the limit as x goes to 3 from the left of the function is equal to infinity. All right, so that's one way to do it. What I like to do better is say, okay, I like this better. If you remember this from last year, method 2. Say, okay, well, I know we got a vertical asymptote, so I know that the numerator is approaching -2 times 3. I know the numerator is approaching -6. And I know that the denominator is approaching 0. So we know that -6 over numbers getting closer and closer to 0 either go to -infinity or infinity. So then we got to see if that number is positive or negative. And the number is, so if I put in 2.5 minus 3, 2.9 minus 3, 2.99 minus 3, I'm going to get a negative number. So -6 divided by a negative number is going to be a positive number, and a -6 divided by a number really close to 0 is either going to go to positive infinity or negative infinity, so it's going to positive infinity. So that's the other way to explain it. All right, I think that is a much faster explanation. Okay, if you want, I'll show you real quick, how to graph this function. So you go to y equals, you get the y equals button, and then we'll do a parenthesis for -2x divided by a parenthesis for x and then -3. And then you can graph this. Now my window's in a weird spot. So now I'll go window and, no, I'll go zoom. Zoom. And you can go to Z standard. That's usually, that's -10 to 10. Okay, and then there's the graph. So here's x equals -3. As we approach it, it's going to infinity. Okay, now I don't want you to do the problems that way, all right? Because most likely these will not be problems that you'll be able to do. What am I trying to say? These are problems that you will not be able to do with a calculator on the AP exam. Okay, so now, some other functions to discuss with one-sided limits and continuity. Now, remember the greatest integer function is that step function. So remember with our functions, what we would do is we would look at this and go, okay, this function here, it's got the dot. We're going to fill right 1. We're going to put an open circle normally, and then we're going to jump up 1. Now, let's talk about the changes of this. First of all, what makes inside the function 0? Well, what makes 1/2 x plus 3 equal to 0? Well, if you subtract 3, you get 1/2 x equals -6. Okay, you get 1/2 x equals -6. So x will equal what? -12? Or no. I skipped a step. 1/2 x equals -3. So then when we double both sides, x will equal -6. I said the answer. So we're going to go over 6, 1, 2, 3, 4, 5, 6 to the left, and down 1, 2, 3, 4. We'll put a dot there, solid dot. Now normally we fill right 1 and we jump up 1. Inside the function, there's a 1/2. And if you remember stuff inside the function makes things go a little haywire. So if you remember, inside the function, the number in front of the x multiplies it by its reciprocal. So it's going to double it. So we're going to fill right 2, 1, 2, put the open circle. And then we're going to jump up. There's not a number outside the function, so we'll just jump up 1. I don't know why I just jumped up 2. My fault. Okay, so a couple things that I could do. I could say discuss continuity. Well, this is discontinuous, or basically this is tricky. I'm going to say where it's discontinuous. Continuous at all even integers. 0 to, that's where I have all the jumps, all even integers. We also write that the 2n is where it's discontinuous. So I'm not really going to make you say where it's continuous. It's just discontinuous at all 2n's, where n belongs to the set of integers. If you remember kind of doing that from last year. Okay, now, why is it discontinuous? It's discontinuous because the limit at x approaches all those places of the function does not exist. Okay, so that means at every place those are non-removable. Okay, now one-sided limits here, to add to this, if we go the limit as x goes to, let's go to 0 from the right. So the limit as x goes to 0 from the right of this function is staying at -1. Come in, the limit as x goes to 0 from the left of this function, as I go this way, is going to -2. Okay, so it's going to -2. All right, so now looking at this last problem down here, we got a piecewise function. No, without graphing it, I'm going to ask you to do this. You could graph this up here or whatever, but 4 is kind of the tricky spot, all right? So at 4, the value's 6, okay? So that's f of 4. It's 6, all right? As we approach 4 from the right, if we're coming from the right, we're putting in values bigger than 4. So all that would mean is this would be the same as the limit as x goes from 4 to the right of x squared plus 1. And since it's continuous there, we'll just put that in and we'll get 4 squared plus 1 is 17. So that is 17. Okay? If we approach 4 from the left, well, if we're coming from the left, x is less than 4. So then we will put in the limit as x goes to 4 from the left of 2x minus 3. So if we do that, we'll put 4 in here and we'll get 8 minus 3, and that, this was supposed to be up here. Limit as x goes to 4 from the left of 2x plus 3. That looks like a negative. From the left of 2x plus 3 is 8 plus 3 is 11. And so as we went from the right and the left, they're not the same, so this limit does not exist. Okay? All right, now, I know you think you're done, but I do want to show you a couple more. I didn't have a lot of examples like this, so I just want to do a couple more. Okay? So let's look at a couple more with asymptotes. You don't have to necessarily write these down. You can if you want to put them on another sheet of paper, but I definitely want you to see a couple more. Limit as x goes to -2 of 3x over x plus 2, and the limit as x goes to -2, sorry about the vacuum, -2 of 3x over x plus 2. And we'll do this one from the left, we'll do this one from the right, okay? So let's do 3x squared, and let's do 3x squared, okay? So here, if we put -2 into this, the numerator is approaching 4 times 3, 12, and the denominator is negative. The denominator is approaching 0, and is negative. Now, I kind of did a crappy job of this. I should have mentioned that, hey, -2 here, the top's going to 12, the bottom's going to 0, so we have a vertical asymptote. So I want to know, is it going up or down? So if the top is going to 12 and the denominator is going to 0, then our number is going to infinity or negative infinity. If the top is positive and the bottom is negative, it's going to negative infinity. Okay? So that is our answer. That's a fine explanation. Okay? The limit as x goes to -2 from the right, if we put in -2 on the top, the numerator is going to 12 and the denominator is going to 0 and is positive, because you're putting in numbers bigger than -2, like -1.9, -1.5, so that would be bigger, all right? So then if that's the case, then we're going to go to infinity, but it's going to be positive infinity, okay? Let's do one more. Limit as x goes to, let's do 7 from the left of 7 minus x over x. So we're going to 7 on top, we're going to 0 on bottom. So the numerator is going to 0, or going to 7, I'm sorry. And the denominator is going to 0 and is, so if I put in numbers to the left, I'm putting in 6.5, 6.9, 6.99. So 7 minus those numbers, we would get a positive. So we're taking a positive divided by a number very close to 0 that is positive, so that would be going to infinity. All right, so I just wanted to show you a couple more.